Now, there are some questions where we are given a boat that is moving from one end of the shore to the other end of the shore. In other words, it is moving across the river. Now, in a question like this, again, they give us that there is a water current that is moving. And this current is going to be meeting the boat. Okay? So you find that the boat is moving from one end to another end, and then there is a current that is coming to meet this boat at an angle of 90 degrees. Okay? Questions like these are known as the river boat problems. And so you want to look at questions like this. For example, let us start with the first one. It says that a motorboat traveling at 4 meters per second east encounters a current traveling at 3.0 meters per second north. Then the first part is saying that what is the resultant velocity of the motorboat? Number 2, if the width of the river is 80 meters wide, how much time does it take the boat to travel shore to shore? And C, what distance downstream does the boat reach the opposite shore? So in this question, we are told that the boat is traveling at 4 meters per second, okay, and it encounters a traveling wind current that is traveling at 3 meters per second in the northern direction. The boat is traveling in the eastern direction, okay, and so when they give us a question like this, the first thing is to make a sketch, and you start with the velocity of the boat. So if it is traveling in the eastern direction, we draw an arrow, we draw a line, we draw a vector that is moving in the eastern direction, and this is going to be 4 meters per second. Remember that we are saying that the velocity of the boat is what we start with. Then the current, the velocity of the current is going to come next. Now the current is the wind, the water. The current is the water that is moving and is meeting the boat. So if the boat is moving in the eastern direction and the current comes and meets the boat when the current is moving in the northern direction, it is going to change the direction of the boat. So we draw the sketch for the current again. It is going to be like that. It is moving in the northern direction at 3 meters per second. Now, these are vectors, and we said that if you have two vectors, we can use different ways of adding them. Now, in this case, you observe that they are going to be meeting at 90 degrees. So that means that if I draw, remember I start with that one of the boat, I draw the vector for the boat, that is 4 meters per second. Where it ends, using the triangular law, we draw that one of the, for the current, which is going to be 3 meters per second. So then the resultant is going to be the line that joins from the start, from where the boat starts, up to where the current ends. So this angle here is equal to 90 degrees. Now in this diagram, you observe that we have 90 degrees here, so we can use Pythagoras' theorem to find the resultant, which is going to be this one here. So we're going to say r squared is equal to a squared plus b squared. So we get r squared is equal to 4 squared plus 3 squared. So r squared is equal to 16 plus 9, and r squared is equal to 25. Therefore, our resultant r is equal to 5 meters per second. Okay, so that is going to be the resultant. Then the next part was saying if the width of the river is 80 meters wide, how much time does it take for the boat to travel shore to shore? Now, if this is our boat, okay, the boat is starting to move from this end and it is going to this end. We are crossing the river. Okay, so this is a shore and this one is also a shore. Okay, so if that is the case, now they've given us the velocity of the boat. The boat is going to be moving from here up to here, so its velocity is 4 meters per second. Now if they've given me the distance from here up to here, that is 80 meters, I can be able to get the time, because we're going to say that distance is equal to speed times time. My distance is equal to 80, speed is equal to 4, or velocity is equal to 40 divided by 4 divided by 4, we get t is equal to 20 seconds. So that will be the time taken. Then, what is the resultant? Then the third part, what distance downstream does the boat reach the opposite end? Now, to get the distance downstream, we are asking, what is the distance the boat was supposed to move from here up to here? But because of this current or the water that is moving, that is meeting the boat, it makes the boat not to reach the other end at this end. Instead, it makes it to reach at this end here. Now, to get this distance, the boat moved from its original set point up to the new set point. What I do is to use the speed of the current. Okay? So after getting the speed of current, you multiply with the time. Now, the time it takes to move from shore to shore is the time it takes to move downstream. So if the time I take to move from here up to here is equal to 20 seconds, it is going to be the same time I move from here up to there. Okay? So this time which you got here is the same time which you are going to use here. And so you are going to come and say distance downstream is going to be given by speed times time. And now the speed, you're going to use the speed of the current, which is going to be 3 meters per second. So it's going to be 3 times 20, which is going to equal to 60 meters. Then, maybe the last part, the angle. What is the direction of the boat? To get the direction, you observe that this is 3, this is 4. I can use tangent, that is tan theta is equal to opposite divided by adjacent. So tan theta is equal to 3 divided by 4, from which you're going to get theta as equal to 38.66 degrees.
The next question is telling us that a motorboat traveling at 4 meters per second east encounters a current traveling 7 meters per second north. What is the resultant velocity of the motorboat? And that is the first part. The second part, if the width of the river is 80 meters wide, then how much time does it take the boat to travel shore to shore? And part C, what distance downstream does the boat reach the opposite end?
The next question, we are given that the velocity of the boat is 4 meters per second. So let me say VB is equal to 4 meters per second. And they've given me that the velocity of the current, remember that the current is the water that is moving. Okay? So if I have a boat, it is moving that direction, for example, and there is a current that is moving upwards. This current is going to be interacting with the boat. Okay? Now, as it interacts with the boat, it's going to make it change the direction in which it is moving. Therefore, if the boat was supposed to move in that direction, we find that as a result of interacting with these currents, we find that the boat changes direction and it moves in that direction. So, the velocity of the current, they've told us that it is 7 meters per second. So, now they told us that the boat is moving in the east and the current is moving in the north. Now we start with the velocity of the boat at all times. So you come and you draw. That is the boat. It is 4 meters per second. And then we have a current that is moving in the direction. Okay. This is 7 meters per second. And then we can join them together. Now, because the boat is moving in the eastern direction and the current is moving in the northern direction, they are always going to meet at 90 degrees. Okay? And that's why here, in this case, we're going to be using Pythagoras' theorem. So, if this is C, you're going to say C squared is equal to A squared plus B squared. So, C squared is equal to 4 squared plus 7 squared. So, C squared is equal to 16 plus 49. So we get C squared is equal to 65, from which I'm going to get C is equal to 8.06 meters per second. This is going to be the velocity of the resultant. Okay?
Then to get the direction of the resultant, you can use a protractor. How? You put your protractor here, and then you measure the angle. In other words, you put it like this. Protractor from the starting point, you put it like that. Then you're going to measure this angle here. Okay? And that angle is going to equal to 60.26. Or we can use Pythagorean, tan, that is tan theta. This angle here is equal to theta, is equal to opposite, that is 7 divided by 4, from which you're going to get your theta as equal to 60.26 degrees. Then the next part was saying that what if the width of the river is 80 meters wide, how much time does it take? So the width of the river, remember that the river from here up to here, that is going to be the width of the river. So they've already given us the velocity at which the boat is moving. So if the velocity is equal to 4 meters per second, the width has been given as 80 meters. That means that I'm going to use that distance is equal to speed times time. My distance is equal to 80. It's going to equal to 40, from which you're going to get t is equal to 20 seconds. Now remember that the time it takes to move from here up to there across the width of the river is the same time it takes for the boat to drift downwards, or it is the time it takes to move from here up to here. So if the distance, the time here is equal to 20 seconds, that means that the time here is also going to be 20 seconds. So if they tell us to find the distance downstream, what I'm going to do is that distance is equal to speed times time. So my speed is equal to 7. There, the distance downstream, we use the speed or the velocity of the current, and you multiply by the time, which is equal to 20, from which I'm going to get 140 meters. So the distance downstream that is moved is going to equal to 140 meters.